This is lesson 9-2, multiplying and factoring. In example 1, we need to multiply a monomial and a trinomial. A monomial, I hope you remember, is one term, and a trinomial means 3 terms. So in order to multiply these together, all we need to do is distribute. So we have negative 2g squared times 3g cubed. We need to multiply our numbers first. Negative 2 times 3, negative 6. G squared times g cubed. When we multiply powers with the same base, we need to add our exponents. So we have g to the 5th. And then we'll do negative 2g squared times 6g. Again, multiply our numbers first. Negative 2 times 6, negative 12. G squared times g gives me g cubed. Again, I'm adding those exponents. There's that imaginary 1 there. And finally, we have negative 2g squared times negative 5, negative 2 times negative 5, positive 10, and then we need to tack on that g squared. We have no like terms. There's nothing we can combine or simplify, so we are finished. From lesson 9-1, hopefully you'll remember if we were asked to name it, it would be called a 5th degree trinomial. All right, let's try a quick check. How about quick check 1c? Again, they just want us to simplify, so we need to distribute. 2x times x squared, 2x times x squared, x cubed. Remember that imaginary 1. If you don't have an exponent, there's always that imaginary 1. Next, we'll multiply 2x times negative 6x, 2 times negative 6, negative 12, x times x with that imaginary 1, x squared, and finally, we'll multiply 2x times 5. 2x times 5 gives us 10x. Again, we don't have any like terms, so there's nothing else we can do, and we are finished. If we were to name this expression, we would call it a cubic trinomial. Cubic because the highest degree is 3, trinomial because we have 3 terms. Moving right along to example 2. Now they want us to find the GCF of the term. Well, if we're going to do that, we need to have a little review about what a GCF is. GCF means greatest common factor. And you should remember doing this years ago. But let's do a little review over it. We'll use some easy numbers. Let's find the GCF of 16 and 24. You should remember finding all the factors of each of your numbers that you were trying to find the GCF for. If you're going to find the greatest common factor, then you need to find all the factors. So 16 would be 1 times 16. Those are some factors. 2 times 8 would also give you 16. And finally, 4 times 4 would give you 16. Those are all the factors of 16. If we were to do 24, we'd start with 1 times 24 is 24. 2 times 12 is 12, 3 times 8 is 8, and finally 4 times 6 is 24. Now if we're going to find the greatest common factor, then we want to find the largest number they both have in common, which is this 8 right there. That's the greatest common factor. That's probably the way you're used to doing it. However, that's not the method we're going to use on our example, so let's practice using that method. Another method for finding the greatest common factor is to factor tree or find the prime factorization for both of your numbers. So 16 would be 4 times 4. Neither one of these are prime, so we have to keep going. 2 times 2. And the same with this 4, 2 times 2. Therefore, 16's prime factorization is 2 times 2 times 2 times 2. We'll do the same thing with 24. 24 is 4 times 6. 4 is not prime. We break it down to 2 times 2, and 6 can be broken down to 2 times 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. Then if we want to find the greatest common factor, we need to highlight all the things they have in common. They each have this 2, another 2, and one more 2. Then if we multiply across 2 times 2 times 2, we get a GCF of 8, which is what we got the first method that we tried. That's what we're going to do. We're going to use this same method on our polynomial. So I'm just going to start by writing them vertically. 2x to the fourth, 10x squared, and 6x. And then we will write down their factors. So 2 is prime, so I'm just going to write down a 2 times x times x times x times x. 10 is not prime, so I'll factor it down to 2 times 5 times x times x. Also, 6 is not prime. 6 would be 2 times 3 times x. Now we'll do the same thing we did down here. I'm going to highlight what we had in common. They all have a 2 in common. They also all have an x in common. They have no other numbers or letters, so we're finished with that. Our GCF then is 2x. That is the greatest factor that all three of these terms have in common. Let's try one more. How about quick check 2a? Again, we're wanting to find the GCF of these two terms. So our first step is to write them vertically. And then we'll factor them. 5 is prime. 5 times v times v times v times v times v. And 10 is not prime. It is 2 times 5 times v times v times v. Now we just need to highlight what they have in common. They both have a 5 and 1, 2, 3 v's. So when we multiply across, we end up with a GCF of 5 times v times v times v, 5v cubed. Let's do one more quick check. We'll go ahead and do quick check 2b, which is 3t squared minus 18. Again, we need to find the GCF. So I'll write them vertically. 3t squared, 18. 3 is prime. 3 times t times t. 18 is not prime. 18 would be 6 times 3. 6 is 2 times 3 times 3. And we have nothing else, so the only thing we have in common is this 3 right there, GCF of 3. Now what you may have noticed from B and also from this example here is that I completely ignored the negative. And that's what we're going to do when we find the GCF. We don't need to put the negative in there. We just want to know what the greatest common factor is, so leave it out. All right, moving on to our last example, example 3. Now they want us to factor this trinomial. By factoring it, they mean pull out the GCF. If we pull out the GCF, we will have factored this trinomial. Basically, we're going backwards from example 1. So let's first find our GCF. I'll take my three terms, 4x cubed, 8x squared, and 12x, and I'll break them all down into their prime factors. 4 is 2 times 2 times x times x times x. 8 is 2 times 2 times 2. X squared is x times x. And finally, 12 would be 2 times 2, which is 4, times 3 times x. Now, just like we did in that last example, I'm going to highlight all the things they have in common. They all have a 2. They all have one other 2. And they all have an x. I don't see anything else they have in common, so that means our GCF must be 2 times 2 times x, 4x. Once you have your GCF, then you need to pull it out. Pull out your GCF from your original trinomial. So I have 4x times what will give us 4x cubed minus 8x squared plus 12x. And you'll see that our answer is going to look like the problems we were solving in example 1. So I have 4x times what would give me 4x cubed. Well, I already have the 4 taken care of. So x times what would give me x cubed? Well, x squared. Then I have this negative 8x squared. 4x times what would give me negative 8x squared? Well, 4 times negative 2 would give me negative 8, and x times x would give me x squared. So 4x times negative 2x is negative 8x squared. Finally, 4x times what would give me positive 12x? Well, 4 times 3 would give me 12. 4x times 3 I end up with 12x. Now if you take just a moment and you look at what we've done here and what we had over here, you may notice something interesting. Let's look at this term right here. We have 4x times x squared. If you notice what's left over here, 4x times x squared is 4x cubed. X times x is x squared. Interesting. Okay, if we look here, 4x times negative 2x, well, look what was left over here. 4x times negative 2x, negative 8x squared, 2 times x, 2x. Make sure, though, that you notice that we had to put in that negative. You have to pay attention to the sign. Finally, we had 4x times 3 gave us 12x, and if you look at 12x and our factorization of it, 3 was the only thing that was left. Let me get a different color here. 3 was the only thing that was left. I hope that makes sense. If not, let's try one more. Quick check 3C. Again, the first thing we're going to do is find the GCF. 6m cubed, negative 12. Ooh, let's leave out that negative. We don't need that. 12m squared, and finally 24m. Again, I'll just factor all these. 6 is 2 times 3 times m times n times m. 12 is 2 times 2, which is 4, times 3 times m times m. And 24 is 2 times 2, which is 4, times 2, which is 8, times 3, which is 24, times m, 24m. Let's find what they have in common. They all each have a 2. They all also each have a 3. And they each have an m. Therefore, our GCF is 2 times 3, which is 6, times m, 6m. Now we'll do just what we did last time. We're going to pull out the GCF from our original trinomial. So I have 6m times what would give me 6m cubed minus 12m squared minus 24m. Now we can use our little trick that we just learned, and we can look at what was left over when we did our factoring and finding our GCF. So in this case, we have m squared left over. 6m times m squared would in fact give you 6m cubed. And since this is positive, my m squared is also positive. If we look at our next term, it's negative, so I know that my next term is going to be negative inside my parentheses. And if I look at what was left over, it was a 2 and an m. 2 times m is 2m. So 6m times negative 2m gives me negative 12m squared. Finally, my last term, negative 24m, it is negative, so mine is as well. And we see what we had left was 2 times 2, which is 4. And that's our last term, 4. 6m times negative 4, negative 24m, and we are done factoring. All right, if you have any questions, I will see you in class.